Hi, good day to you. Welcome to my channel. Today's topic in this video will be on excretion. The difference between secretion and excretion is that secretion is for producing useful substances for the body. Excretion is for removal of waste. So you secrete like skin oils, tears, mucus, to help the body. Excretion is to remove waste. That's done by the lungs, kidney, and in this topic, we will specifically look at the processes in the kidney. So in the body, there are many processes that are going on, largely categorized as catabolism, where things are broken down, and anabolism, things being built up, and together they are called metabolism. And these reactions produce waste products which can be harmful if they are kept in the body. So there must be a system in place to remove all of them. And this process is called excretion, to remove metabolic waste products from the body. And this is the structure and location of the kidney and bladder in the body. The renal arteries will bring blood into the kidney for filtration process and returns the filtered blood in the renal vein, and the waste products will travel down the ureter and be temporarily stored in the bladder for eventual removal via urethra as urine when you pee. So don't confuse ureter and urethra. Okay, and this is the basic structure of a kidney. There's not too much emphasis on the exact anatomy of a kidney, so you don't have to stress yourself too much over how a kidney actually looks like. You have to know mainly the processes, who goes what and where, which is more important for this chapter. Okay, so let's look deeper and closer into a kidney. So the main event takes place on a nephron, and a nephron begins with a Bowman's capsule. Then it has this proximal convoluted tubule. So it's just bombastic name to say proximal means near. So it's near to the Bowman's capsule. Convoluted means twisting and turning. Tubule means tube. Okay, so it's a near twisted tube near the Bowman's capsule that is in the cortex, and then it bends down all the way into the medulla, forming a loop of Henle, and then going back up into the cortex as a distal convoluted tubule. So distal means far, the twisted tube that is far away from the Bowman's capsule. These are just bombastic names. Okay, so finally it goes into the collecting duct, and finally releasing the contents into the renal pelvis, and the renal pelvis will bring everything into the ureter. Okay, with basic anatomy out of the way, we go into the main event, that is the urine formation, formed by two ways: ultrafiltration and selective reabsorption. So ultrafiltration only happens in the renal corpuscle, okay, which is the Bowman capsule and several arterioles. So the entering arteriole is called the efferent arteriole, and the exiting arteriole is called the efferent arteriole. So A and E is just the difference. You just have to remember that A comes first, then E. And the efferent arteriole is wider than the efferent one. So with blood pressure of the heart pumping, the ventricle will push the blood all the way in from a thick tube into a thin tube. So this will force a lot of materials out of the partially permeable membranes of the glomerulus, and these will be captured in the Bowman capsule. All the filtrate will be captured. Okay, and in this part, waste material as well as useful materials are also pushed out of the blood. And to recapture all the good stuff back into the body, selective reabsorption has to take place. And selective reabsorption takes place at all the convoluted tubules and the loop of Henle. Basically, that is just it. And finally, the end product will be just waste that is collected at the collecting duct to be led into the renal pelvis, and finally into the ureter, into the bladder, and out via the urethra. And this below shows a basic composition of urine. Okay, and basically that is just it for urine formation. Next, we go on to osmoregulation. So another bombastic word. So osmo means water, regulation means regulation. Okay, so if there's too little water, you have to increase it by some means. Too much water, you gotta reduce it by some means. Okay, and in this case, the brain produces the anti-diuretic hormone from the pituitary gland in the hypothalamus that does this job. And how I remember is that there's a letter D, so it's like a dryer. It dries things up. Okay, so for example, if you have less water in the body, the hypothalamus senses it and produces more ADH, and having more ADH, more water is reabsorbed, and therefore you have smaller amount of urine produced. So it's like drying up the kidney. However, if you have a lot of water in the body, for example, drinking too much, this will stimulate the hypothalamus in the brain to produce less ADH. In this case, less water is reabsorbed, therefore more urine will be produced to achieve a constant internal environment of a certain water potential in the body. This process of maintaining constant internal environment is called homeostasis, which we'll be covering in future videos. And of course, maintaining a healthy amount of water potential in the body is important for cells. If not, these will happen. Recall the earlier video, link in the top right corner. And finally, we'll be talking about kidney failure and the process of dialysis. Kidney fails for a large variety of reasons, and therefore there's this external machine that patients can channel their blood into for the machine to clean the blood. So it's like an external kidney. So blood is channeled via a vein into the dialysis machine, and is submerged into the dialysis fluid, and it exits and returns into the patient's vein. And the machine has the following features, which I think is quite common sense. I won't go too much into detail. And that is it for this chapter. It's pretty standalone and pretty small and simple. Okay, I'll see you in the next video. And that is all for today. Hope you enjoyed this video. Give it a like and subscribe. Share it with somebody that needs to see this. And I will see you in the next video. Bye.